All right, so let's talk about inverses. Inverses have to, first of all, be one-to-one. Remember, to be a function, it's input, one output. One-to-one means for every output, there's exactly one input. Once we have an inverse existing, then that means that we can send a value, say A, over to B, and then we can send that value back by the inverse. So A goes to B by F, the function, and then B goes back to A by F inverse. That's F to the minus 1. Now another thing that has to happen, or consequently has to happen, is that the domain of the function is the range of the inverse, and the domain of the inverse is the range of the function. Okay, so they are connected to each other. So if I know the domain of F, I know the range of F inverse. If I know the domain of F inverse, I know the range of F. Also, an interesting thing that happens is if you graph a function x, f of x, and you graph the identity function y of x, then there is a reflection around that line y of x that will give you the graph of f inverse. So you never really have to know it just to do the graph. You just have to know the graph of one, and you know then the graph of the other. These are inverses of each other. So I have f of x is equal to minus 3x plus 5, and I have g of x, which is equal to x minus 5 divided by negative 3. Now, the one property we know about inverses is that if you compose them together, you should get x. So in other words, I want to see if f of g of x equals x, which equals g of f of x. If that's the case, then I know they're inverses. So if I take f of g of x, that would be f of all of this stuff, x minus 5 over negative 3. Now I plug that in where the x is here, so I have negative 3, 5 minus x minus 5 over negative 3 plus 5. The 3's divide out, leaving x minus 5 plus 5, which is x. That way worked. Now let's go the other direction, g of f of x. So g of f, which is negative 3x plus 5. Now we plug that in for the x here, so that's minus 3x plus 5 minus 5 over negative 3. Those subtract off, and those divide out, leaving x. So therefore, f and g are inverses of one another. So what we could do is we could write f of x is equal to g inverse of x, or I could write that g of x is equal to f inverse of x. Okay, so let's go through the steps to find an inverse. So let's say we have the function x over x plus 2, and I want to find the inverse. Now the way the book says to do it is it says solve for x and then flip the x and the y's. Honestly, it doesn't make any difference. So I always say it to do it this way. First of all, rewrite it without the f there. Put a y in here. At this point, you can just solve for x. Or we could switch them now and then solve for y, which is what I like to do. So let's put x here and put a y over here. So now I want to solve for y. From here to here, I switched x with y, and from here to here, I renamed f of x y, since they are equal to each other, right? So those are my steps so far. So now I want to get that y together as one thing. So I'm going to multiply this over to their side. So I get x is times y plus 2 is equal to y. Distribute my x. So I get xy plus 2x is equal to y. All right, I'm going to subtract let's do it this way. Let's just subtract this over here. So I have 2x is equal to y minus xy. Factor the y out. And then divide this piece over to the other side. So we get 2x over 1 minus x. Now the last step is to put in the notation. So I get f inverse of x is equal to 2x minus 1 over x. And then I could go back to the other stuff we were doing and check. So the last part is to check, and we'll skip that because that's really the same thing we did before. You just plug it in and see what it does.